So if you've been building ICP applications for a while, then you might have realized that it can be quite complex to create backend data structures and to query them effectively, so to get good performance out of your application. And you might have asked yourself, like, well, wouldn't it be like really nice if I could just use a regular database? And well, it turns out you actually can. And the secret sauce that what makes this possible is spelled WASI, the WebAssembly System Interface. WASI is kind of a magic thing. What WASI does is that it defines a system interface between your WebAssembly components and the world that sort of surrounds them. And ICP canisters are essentially WebAssembly components. So we should be able to use WASI, right? A community-run project called WasmForge has created a tool that allows us to process these WASI-compiled canisters to make them run on the ICP. And essentially what WASI to IC does is that it injects ICP equivalents of these WASI system functions. And those system functions can be stuff like file system access or time access or randomness, these like really low level system functions. And once we can run a WASI compiled canister on the ICP, that really opens up the door for us to run any third-party tool or system that can be compiled to WASI. And that is a lot, and it includes SQLite. So WasmForge, in addition to creating this WASI to IC tool, they have also created a library that makes using SQLite on ICP really straightforward. It comes packaged with a pre-compiled version of SQLite, so you don't have to go through the whole hassle of compiling that old C library yourself, and which means that you can focus entirely on building your application logic instead of spending time wrestling with that low-level stuff. So yeah, these libraries greatly sort of reduces the barrier to anyone wanting to get started using relational databases inside their canisters. So in this video, we're going to take a closer look at how to structure a full stack application that makes use of SQLite. And the application here does everything you would expect from a regular Web 2 style full stack application. So for instance, to set up the database, we will run migrations, and those migrations will see the database with some initial data and a nice schema. And we will create a bunch of endpoints where we have a backend canister that sort of acts as the API and exposes a number of endpoints to the front end. And those endpoints will accept the DTO objects, these data transfer objects, that allows us to do fully typed queries from the front end. And these DTO objects, of course, will be validated before we accept them, like before we do any changes to the database. And in the front end, then we will use modern tooling such as React, TanStack Query, and TanStack Router to get some structure and to run these queries in an efficient way. In this video, I will walk you through the most important parts of the code base, the full stack. But before we dive in, let's have a quick look at the finished application. So the demo application is really straightforward. It's a basic listing of persons. It's just a one-page application that displays a list of individuals, and you can add one. So let's add Joe, 110, 101, and we'll see if Joe appears here. Yeah, there's Joe. So we can add people. We can change their name. Let's call him Joseph instead. Saved, and we can delete people, and that's it. When you get started using SQLite on ICP, I recommend you to fork this template as a starting point, because then you have all the structure in place. It saves you a bunch of time not having to scaffold that from the start. Let's have a look at some of the code. I wanted to start at the cargo.toml file, not that one. But this one for the backend, to briefly show you what dependencies we added in addition to the default ICP dependencies, the CDK and the Candy dependencies, and some SERDE and SERDE JSON that we will use for the data transfer objects and serialization later. We add the SQLite, the ic-rusqlite crate, as well as the ic-sql-migrate, which is a small open source library that I have contributed that helps you get started running SQL migrations to set up your database easily. So one thing to note here is that we add these crates to our main dependencies, but we also need to add SQL-migrate to the build dependencies, and I will tell you why in a bit. Before we look at more of the Rust code, let's look at the migration. So this migrations library, it runs standard SQL files to allow you to set up your database schema. I have created a migrations folder in the root of the project, of the backend project here, migrations. And the first migration is the initial one where we set up the database schema. In our case, this is very, very simple. We have only one table. We give it an ID that is an auto increment ID. We store just the name and the age of the individuals, and we set some validation rules, and I will get back to that. I believe it's important in a full stack application, a well-structured application, that we have validations at various levels of our application, and this is like the core. The most important place to protect our data is at the data storage layer, right? So in this case, we want to ensure that the name is not too long. We allow only names that are up to 50 characters, and we say that the age has to be between 1 and 150 years old. But we have also an additional migration, and that is the person's seed. So we are running an additional SQL file here that inserts a few names into the database, so we have something to look at, something to work with once we deploy the application. Up next, I thought we could take a look at the lib.rs, and let's start with looking at the IC lifecycle function. So we have the init function, and we have the pre-upgrade, and we have the post-upgrade functions added to our canister. And in both the init and in the post upgrade, we run we run the migrations function. We start out by acquiring a connection to the database. This is a function provided to us by the Rust SQLite library. So it manages the connection handling for us. And worth noting here is that we don't need to do stuff like connection pooling or anything like that, because the first, SQLite doesn't handle concurrent queries, which is totally fine by us when on the IC, because the messages that are coming into an IC canister are handled sequentially. So we handle at most one query at a time. So the whole setup is way simpler than when you're in a regular Web 2 environment. Of course, this has performance implications, but that is the nature of running things on a blockchain. We cannot run things in parallel. We have to run them sequentially. So we acquire a connection, and we call the up function. and submit the connection, and the migrations. And this is interesting, the migrations. And what are the migrations here? How do the migrations go from being static files in our local file system to being available inside the canister? And that is with the help of this macro called include. You can see here that the include function returns a reference to an array of migration objects. So somehow the SQL files that we placed in the migrations folder have been turned into migration objects instead. And a migration object is an object or a struct that has an ID and a static string with the SQL data. And how this happens is, or where this happens is in the build.rs file. So the build.rs script is run before you compile the canister. This build script is run by Cargo, and here that is also why we needed to include ic-sql-migrate as a dependency, both in the regular dependency section and in the build section, to make this the crate available to this build script. So what this build script does, it just calls the list function of the migration crate, and provides the name of the folder. And what this script does, or this function does, is that it creates some Rust code. Actually, it creates this array of migration objects that we later can include in the lib.rs file. So now that we have listed the SQL files, turned them into migration objects, imported those migration objects into our main lib.rs, and we have run the migrations, and we run it both on init, that is the first time we deploy the canister, and we run it on post upgrade every time we upgrade the database to ensure that we have always run the latest migrations. And next up, let's have a look at the API endpoints that this canister exposes. Here they are in the Candid UI interface. We have some basic person count function that returns 5. We have 5 records in the database. We have the person the create, we have the delete, we have the get, we have the query that can list persons for us, and we have the update. I have created one file each for these API endpoints. This is highly opinionated. Many people like to bunch all their canister endpoints together in one Rust file, code file. I believe it's a good structure to divide them up into one file per API endpoint. And in addition to that, as you can see this is the person count function. The only thing that it actually does is that it is calling the person manager and the function count on the person manager. So I also am a big fan of creating these manager structs or classes, you would call them in other languages, where we then bunch together the data access logic. And the reasoning for having this separate, you will say, first I create separate files for all the canister endpoints, and then I bunch everything together in the manager anyway. And the reason for that being is that I believe that the controller should be the function that accepts user input, does validation, does authentication, etc. It should not be so interested in sort of the business logic. And in this case, we don't have that much authentication and that kind of stuff. But that is something that we would have added to these controller functions if this would have been a more advanced application. Then we let the person manager be very clean and just care about the business logic and the storage of the data. So separation of concerns, I'm a big fan of. I mentioned DTO objects, the data transfer objects. I believe that also is a good practice to create specific objects for essentially for each and every API endpoint. But because most often you have like specific, even though the objects might be fairly similar, you know, a person, it contains only the name or the age. But if you know, when you update a person, you want to be able to update the name or the age. But when you create a person, you need to have both the name and the age. So the objects are similar, but they are actually not the same. So that is why on the person create endpoint, I've created the person create DTO. Let's have a look at how that looks, because I came up with a rather neat way of doing input validation on ICP. So the person create DTO, the data transfer object for creating a person, contains two fields, the name and the age. And as you can see, I haven't used the sort of the raw data types here, but I have created a high level data type called name, and one called name and one called age, because I want to add input validation here. And the cool thing is that ICP can do this for us if we just define our structs in this way. So here I define the name data type as a struct, and what I was about to say, what tricks ICP to do the data validation for us. It doesn't, I don't trick it, but it's sort of a, I wouldn't say it's a hack. It's I actually really like it. So we are adding the third deserialization here, the try from. We say that we will implement the try from string. So basically when we receive the input in the controller function, it comes as a string. The name comes as a string. And here we say that we will actually try to serialize the string into a string. This allows us to provide a custom deserialization function. So here we define a custom deserialization function that accepts a string and outputs a string or a result. And what it does this data validation. So here we have the second level of data validation where we check that the name needs to be between 3 and 50 characters long, otherwise it will return an error. And same goes for the age. We create a struct called age. We add the SERD serialization and deserialization, and just the deserialization, and we provide a custom implementation of the try from method, where we check that the age is between 0 and 150. And here comes the cool part, is that the ICP automatically, if these traits are implemented, will actually automatically run this for us when accepting inputs. So this will be run, this try from method will be run on each input that the controller function receives before it's given to the function, which means that on the person create function here, we know that the SERD try from function has been run beforehand, which is really cool, because then we don't have to add any input validation here at all. Our controller function looks like really nice and clean. I wanted to show you how it looks when the input validation fails. So let's go to the person create function, and remember that we said that the maximum age is 150. We couldn't write some text here, because then this interface would say, this interface checks that we provide inputs of the right type. But of course, it doesn't run our custom validation function at this level, because this is the UI, the candidate UI. So instead, let's provide a valid type, but a number that is too high. So let's create a person with the age of 300 and the name Joe, and we'll see what the call returns. And then the call fails, and it actually traps and returns. So this is the only drawback with this is at the front end. In the front end, you will not receive a nicely structured error object that you have chosen, but instead you will get the more lower level trap error message directly from the IC network. But in this case, I think it's totally fine, because this I would say that this is an exception. You wouldn't expect to ever get this error message, right? Because you also want to do validation in the front end, preventing the users to enter invalid numbers. You should not use this for regular error handling, but use it for the exceptions that you don't expect. But as you can see here, somewhere hidden in this big jumble of text says here, deserialize error, age must be between 0 and 150. So it says here, deserialize error hints at this try from function has been called, and we provided our custom error message, which is really nice. Okay, going back to the person create function, we have received our person create, the data transfer object that we now know is a valid data transfer object, and we call the PersonManager and the create function. And then this function is really straightforward. Since it accepts a person create DTO here, it can rest assured that it has a valid object to work with. It doesn't have to do any additional validation here, so it makes also this function cleaner. And then we're using the function that I showed earlier, the with connection. We get the connection to the database. We set up our SQL insert statement, and we run the query with the DTO name and the DTO age to insert that into the database. And we return that as a result. Either an okay result with the person or an error result with the error message that we get from the database if for some reason the record was not inserted. This result that we received from the manager, we then return in its entirety to the front end. And you could have considered doing a DTO object here as well, but here we return what is the full person object, which is the sort of the one-to-one mapping between what is stored in the database and it's a Rust equivalent, where the ID and the created at and updated at are represented as I64 data types, because they can be quite huge, while the age that we have constricted to being maximum 150, we can use a U32, and then we have the name as a string. Before we hop on over to the front end and see how we connect to this backend from there, I wanted to briefly show you how I generate the DID file that is required to generate the typed declarations that we then use in the front end. Some people believe it's good practice to write your own DID files to really learn the candidate interface specification language. I also believe that it's very convenient to run this export candid script that is available to us. So basically, you just add that to the bottom of your lib.rs. It's included with the IC CDK. It's included by default. Just add it to the bottom of your lib.rs, and then you can generate the DID file automatically. So let's see how that looks. I think it looks okay. The only major drawback when you generate this automatically is that it doesn't respect your return types or result types, even if you have named them. So the results will always be named like result 1, 2, and 3, and so on. But I think it's fine. If you can rename this if you want. Let's hop on over to the front end and see how we connect the front end to this the back end. I will not go into the details on how to set up a React application or how to set up TanStack Router or TanStack Query. Like I said earlier, I would recommend you to fork this demo as a template to get you started. I think we'll start at the package.json to see what specific additions we have made. So, or what packages we have included. So we need to include some, some ICP specific packages, and we also include the ic-usactor package, which is a package that makes it it makes it very simple to set up a React hook that will provide us with sort of some life cycle statuses on your interactions with the backend as well as an easy way to access the backend functions with the typed interfaces and so on. Let's hop on over to the use backend. So here we will create this React hook for our backend canister using the service definition generated for us when building the project, as well as the canister ID, so we communicate with the correct canister, and the IDL factory, that is this typed interface, the API interface of the backend canister. Once we have created this, we can import it into any React component and directly communicate with our backend. But in this case, we actually won't be calling the use backend directly from the React components, because it's a bit you can structure it a bit better by encapsulating these calls into React query hooks. The useQueryPersons uses the TanStack React Query library. And from there, we import the use backend hook that we defined. We instruct the use query hook and say that this hook will only be enabled once the backend is available. And then the query function is very simple. We just call the backend and the person query function, and some instructions on how many users to return and offset, etc. The use create person hook includes a little bit more code, but still it's very straightforward, because this is not a query, this is a mutation. So here we import the backend hook. We use the use mutation hook, we return and use mutation hook from the React Query library, and we define the mutation function that accepts a person create DTO, and this is the DTO object that has been automatically generated for us when we generate the declarations for the backend canister. So really convenient. Let's have a look at how that looks. The person create DTO object, here you can see the age is a number and name is a string, and that's all we need to know this stage. So So the mutation function accepts a person, that is the DTO object. It makes sure that the backend is available, otherwise it throws an error. And if the backend is available, we just call the create function. And once, so this is a nice feature of TanStack Query, is that once we have received a successful response, we call the TanStack Query client, and we invalidate all queries that contain the query key query-persons. So that means that when we create a new person, we instruct TanStack Query to essentially refresh the list of users automatically. So we don't need to pay attention to that in that component, but instead we handle that on the TanStack Query level. Let's have a look at the AddPerson route. And here comes the third level of sort of input validation. And this is I mean, it's a headache, right? Having to validate your data at three levels of the application. We validate the data at the database level. We validate it when we receive it as an input to the controller function of the backend canister. And we validate the data in the front end as well when the user types in the information before, when they push the submit button. Unfortunately, there is no way around this. A good full stack application needs to have data validation on many levels, and there is some code duplication that comes with this. And of course, the risk of you having slightly different validation functions on these different levels. So it's something to pay attention to when structuring your app. What do I want to show you here? Not much really, just that when we have a form here with the name input and the age input, nothing weird here. And then when we call the handle submit function, we call the validate form function here, where we validate the inputs and make sure that the age is required, and age needs to be a number between 0 and 150, and that's it. Once we have validated the form, we call that mutate function that we created in the useQueryPerson hook. Here we import that. So we will await that, and once we have awaited the call to create person, we will navigate back to the main page of the application, happy in our knowledge that the list of users will be automatically refreshed for us, because we invalidate that list once the response from the canister comes back. What else is there? I think that's that might be it. Please post any questions you have in the comment section to this video, and like I said, feel free to use it as a template and as a starting point for your own explorations. And it's worth noting that be really clear about that. The SQLite support for ICP is not an officially supported feature built by Dfinity, but it's a community contributed library. But then again, SQLite is one of the most battle-tested pieces of software ever created. So initial testing shows that it runs really stably on ICP. Good luck and happy hacking.